In this lecture, let's look at two examples of solving transcendental functions by hand. Here's the first example. We want to find the values of transcendental functions without using a calculator. Part A, we add up two log functions. We have log with base 6 of 3 plus log with base 6 of 12. Let's first rewrite them in the form of exponential functions. So a quick reminder, log with base b of x equals to y. This equation is equivalent to b to the power of y and equals to x. So if we transform the log functions we have in the equation, then we get the base 6 to the power of unknown, let's call it a, and that equals to 3. And the second term, we have 6, the base, to the power of some unknown, let's call it b, and this equals to 12. It is not intuitive to find the exponents a and b, such that 6 to the power of a equals to 3, and 6 to the power of b equals to 12. So let's use a property of log. We learned that when we have a sum of two log with the same base, log with base b of x plus log with the same base of y, we can rewrite that as 1 log with the same base of x times y. So I can rewrite this equation as log with base 6 of 3 times 12. 3 times 12 is 36, so this becomes log with base 6 of 36. Now let's interchange this form to an exponential function. So the base is 6, and the solution to this equation is question mark, that is the exponent. And with this exponent, the answer is 36. Now we could easily find the exponent. We know that 6 squared equals to 36. So the answer to this question equals to 2. Now let's look at part B. Let's find cosine of 5 pi over 6. 5 pi over 6 is smaller than pi and squarer than pi over 2. So we know that it will be a point in the second quadrant. 5 pi over 6 also equals to pi over 2 plus pi over 3. So it will be the negative of the x-coordinate when angle equals to pi over 3. That is shown in this figure here. So the angle is 5 pi over 6, and we are in the second quadrant. And from pi over 2 to 5 pi over 6 is pi over 3. So we know that this angle is pi over 6, or 30 degrees. So this x-coordinate will be the negative of the x-coordinate if we move up 30 degrees from the positive x-axis, which is negative of square root of 3 divided by 2. So I highly recommend you to remember the coordinates from the unit circle. The answer to this question, cosine of 5 pi over 6, would be negative of square root of 3 divided by 2. In the last part for example 1, we want to find the inverse sine function of half. Since we have an inverse trigonometric function here, which means the answer is an angle. This equation is equivalent to sine of theta equals to half. Now let's relate this back to the unit circle. So sine theta corresponds to the y-coordinate around the unit circle. Then at which angle does the y-coordinate equals to half? Again, if you can remember the coordinates of the unit circle, you can easily find the angle. So I want my y-coordinate equals to half. Then that would correspond to the angle pi over 6. And since it is an inverse function, where the domain is restricted from negative pi over 2 to pi over 2. So the answer to this question would be pi over 6. Theta equals to pi over 6. Let's look at the second example. Now we want to solve the equations that involve transcendental functions. Part A, we have some exponential function equals to 1000. Here I want to isolate for x, so first of all I can divide it by 3.25 to both sides. I get 1.72 to the power of x equals 1000 divided by 3.25. But the x is still in the exponent, and if you remember from properties of log, there's a property is that we can bring the exponent in front of the log. So I can take ln on both sides. I get ln of 1.72 to the power of x equals ln of the right hand side, 1000 divided by 3.25. Then I use a property. I can bring this exponent to in front of ln. So I get x times ln of 1.72, and this equals ln of 1000 divided by 3.25. And since I have the ln function on my calculator, so I can simply divide it by ln of 1.72 on both sides. So I get x equals ln of 1000 divided by 3.25, and divide this by ln of 1.72. So I plug in the numbers in my calculator. I get x is around 10.564. In part B, the equation is sine theta equals to cosine theta. Sine theta corresponds to the y-coordinates on the unit circle, and cosine theta corresponds to the x-coordinate on the unit circle. So at which angle does the x-coordinate equals to the y-coordinate? If you memorize the unit circle well, you'll know that it is the 45 degrees in the first and the third quadrants. And 45 degrees also correspond to pi over 4 radians. And the x-coordinates equals to the y-coordinates if and only if they have the same sign, that is when they are both positive or when they are both negative. So we only have these two angles. One is pi over 4, the other is 5 pi over 4. But since I can go around the unit circle more than once, so 2 pi plus pi over 4 is also one of the solution. So I can express the solution as follows. Theta could be pi over 4 plus some integer times pi, where n is integer. So it could be 0, plus or minus 1, plus or minus 2, and so on. As long as the terminal edge always align with this line, then the theta would be the solution to this equation. In the last part, we have inverse secant of x equals to pi over 6. Since all the trigonometric functions could be expressed in terms of sine and or cosine, so let's rewrite this equation as sine and or cosine functions. Then we can use the unit circle again. So when we have an inverse function, I can do another inverse function and rewrite the equation as secant of pi over 6, and this equals to x. And secant function is the reciprocal of cosine function. So this is also equivalent to 1 over cosine of pi over 6 equals to x. And what's cosine of pi over 6? Now we need the unit circle again. Pi over 6 is when theta equals to 30 degrees, and cosine function corresponds to the x-coordinate on the unit circle. Here's the unit circle that shows the x and the y coordinates when theta equals to pi over 6. We want the cosine of pi over 6, which means we want its x-coordinates, which is square root of 3 divided by 2. So, x equals 1 over cosine of pi over 6, which is square root of 3 divided by 2. So, x equals 2 divided by square root of 3. And that is the end of the lecture. In the next lecture, let's look at an example of graphs of transcendental functions.